Ever wondered why some elements lose electrons more easily than others? It's all about ionization enthalpy. Ionization enthalpy, you see, is the energy required to remove an electron from an atom. Think of it as the price an atom has to pay to let go of an electron. This energy is measured in electron volts, a unit that may sound unfamiliar, but don't worry, it's just a measure of how much energy is needed to push an electron from one point to another. Now, the ionization enthalpy isn't the same for all elements. It varies across the periodic table. Elements on the left, like sodium and potassium, have a low ionization enthalpy. They're like generous donors willingly giving away electrons. But elements on the right, like oxygen and fluorine, they're more like hoarders, holding onto their electrons tightly. So, ionization enthalpy gives us insight into an element's ability to lose electrons. And that, my friends, is a fundamental aspect of chemistry. Scene script. If ionization enthalpy is about losing electrons, what's about gaining them? Enter electron gain enthalpy. Let's dive into this concept. Electron gain enthalpy is essentially the energy change that occurs when an electron is added to a neutral atom. This energy can be negative or positive. If energy is released when an electron is added, we say the electron gain enthalpy is negative. On the other hand, if energy is absorbed, we call it positive. But why is this important? Well, it helps us predict the reactivity of an element. Elements with high negative electron gain enthalpy are more likely to gain electrons and hence are more reactive. For instance, halogens, the elements in the 17th group of the periodic table, have a high negative electron gain enthalpy. This makes them incredibly reactive, and they are always eager to snatch an electron from other elements. In essence, electron gain enthalpy tells us about an element's eagerness to gain electrons. Electronegativity is a term you've probably heard before, but what does it truly mean? It's essentially a measure of how strongly an atom can attract shared electrons towards itself. Picture this. If atoms were people at a party, electronegativity would be like their ability to draw others towards them. Now, you might wonder, does this attractiveness vary? Indeed it does. As we move from left to right across the periodic table, electronegativity generally increases. This is because atoms with more protons have a stronger pull on shared electrons. What's more, electronegativity also influences the type of bonds formed between atoms. If the difference in electronegativity between two atoms is large, an ionic bond forms, but if the electronegativity difference is small, we get a covalent bond instead. So electronegativity is a key factor in determining the nature of chemical bonds. Now on to valency, another crucial concept in chemistry, but what is it? Well, in the simplest terms, valency is the combining capacity of an atom. Imagine it as a social media friend request. Just like you can accept a certain number of friend requests, an atom can form a certain number of bonds based on the number of electrons in its outermost shell. This outer shell, also known as the valence shell, is where the magic happens. If this shell is not fully occupied, the atom is ready to make friends, or in scientific terms, form bonds. So how does valency impact the formation of compounds? Well, atoms combine in a way that allows them to attain a stable electronic configuration. In this social gathering of atoms, those with incomplete valence shells seek to fill them by sharing, losing, or gaining electrons, thus determining the valency. Therefore, valency is all about an atom's ability to form bonds with other atoms. So, we've covered a lot of ground today, haven't we? We started by diving into the intriguing concept of ionization enthalpy, understanding how it plays a pivotal role in determining the energy required to remove an electron from an atom. From there, we moved on to unravel the mysteries of electron gain enthalpy, the energy change that occurs when an electron is added to a neutral atom. Our journey then led us to the world of electronegativity, where we discovered how atoms can exert a pull on shared electrons. And finally, we demystified the concept of valency, understanding it as the combining capacity of an atom. Each of these concepts is a crucial piece of the puzzle in understanding the fascinating world of chemistry. We hope that you found this journey as enlightening as we did. Thank you for watching. Please like, share, and comment on this video to let us know your thoughts. Don't forget to subscribe to our channel, Facts Academy 0122, for more enlightening videos. Until next time, keep exploring the fascinating world of chemistry.